Hey everyone, and welcome to this explainer. Today we're going to unpack a seriously brilliant mental model. It's designed to help you match the exact shape of any problem you face to the exact workflow it requires. You know that feeling when a project is just dragging on forever? Or on the flip side, when it's moving so dangerously fast you feel like you're going to crash? Well, it's usually because the workflow doesn't match the actual work. By mastering the 4 distinct processes we're going to cover today, you're going to save a ton of time, prevent disasters, and honestly, just stop wasting your own energy. Let's get right into it. Okay, picture this. Imagine a general practitioner's waiting room on a chaotic Monday morning. You've got 4 patients out there, they all need care, but they have totally different profiles. There's a kid with a sore throat, someone needing a routine pre-op consult, a patient who's just starting hypertension treatment, and someone suffering from chronic fatigue where nobody knows the cause. Now, the hidden danger here is pretty obvious, right? If you take that rapid, routine, swab and prescribe approach that works for the sore throat, and you apply it to the complex, unknown causes of the chronic fatigue patient, you're going to cause harm. Applying one patient's process to another's case literally results in delays, misdiagnoses, or really dangerous mistakes. So here is our roadmap for today's explainer. We'll quickly start with the problem of fit and then break down our 4 key processes: primary, first time right, iterative, and exploratory. And finally, we'll wrap up with a handy decision tree for choosing your exact path. Starting off with section 1, the problem of fit and how we actually match work to process. Here's the core idea. A process is never just a matter of personal preference. It's a highly calculated match between the problem you're facing and the actual cost of being wrong. Think of these as 4 totally distinct navigation styles. First, you have the primary process. It's like walking a known route you've taken 100 times. Then there's first time right, where you're meticulously planning a route because frankly, failure would be disastrous. Next is the iterative process, which is basically an adaptive GPS that recalculating as you go. And finally, the exploratory process. That's when you have absolutely no clear route and you're just bushwhacking your way through the jungle to find a path. Moving right along to section 2, the primary process. This is all about walking that known route. So this is the tool we naturally reach for with our most straightforward, familiar problems. The primary process is defined as a single, highly disciplined pass right through your workflow. You define the problem, you find the cause, you design the fix, and you test it. Just once. You're trusting your past experience here, and you just use quick little self-checks between each step to make sure you're still on track. But, and this is a big but, remember, this only works for familiar problems where the stakes are totally recoverable. Meaning if you make a mistake, you can just fix it without the whole world falling apart. To really ground this, let's look at a master mechanic in a local village garage. A customer brings in a car that keeps stalling out. Now, the apprentice had this car previously, and he just swapped out random parts hoping something would work. That took 5 weeks and solved absolutely nothing. But the master mechanic? He uses the primary process. He gathers data to define the problem, figuring out it only stalls when the engine is warm in heavy traffic. He runs a quick bench test to find the cause, spots a specific valve sticking, cleans the valve to fix it, and takes it for a quick test drive to verify. Boom! By using clear quality gates and just one structured pass, he fixes the whole thing in a single afternoon. Speed comes from competence, you guys, not from skipping steps.
All right, section 3, first time right. What to do when failure is irreversible.
Okay, so what happens when the stakes aren't just a stalled car? What if they aren't recoverable? That's when you deploy the first time right process. Think about packing a parachute, right? Or performing open heart surgery, or migrating millions of bank accounts to a brand new server. You cannot learn from failure in these scenarios. There's no undo button for a wrong surgical incision or a collapsed bridge. Because of that, simple self-checks just aren't enough. You absolutely need formal, independent sign-offs at every single gate and layered defenses to guarantee nothing slips through the cracks. I love this insight from the brilliant physicist Richard Feynman. He was reflecting on the tragic Challenger space shuttle disaster and noted that NASA actually knew the O-ring seals lost elasticity in cold weather, but schedule pressures overrode their safety protocols. As he put it, nature cannot be fooled. The first-time right process demands that layered defenses and locked requirements never, ever yield to schedule pressure. If an uninterruptible power supply is going to take 6 extra weeks to install at a hospital, the schedule yields, the safeguard does not. Which brings us to section 4, the iterative process. This is all about learning by doing. So what do you do when mistakes are affordable, but you don't actually know the exact details of the solution yet? The iterative process is perfect when you know your general direction, but doing a ton of upfront planning is honestly just a waste of time. In fact, over-planning here usually just helps you build the wrong thing very efficiently. Instead, you've got to learn by doing. You make cheap, quick attempts, you get super fast feedback, and you let real-world data guide the details. Now, we need to make a really clear distinction here between iterative and incremental, because people confuse these all the time. Incremental progress is like building a new neighborhood, house by house. Each piece is totally finished before the next one even begins. But iterative? That's like an artist drawing a portrait. You start with a really rough sketch of the entire face. Then you shade the whole face. Then you go back and add details to the whole face. True ituration revisits and refines the entire solution with every single new cycle, based on what you just learned. To pull this off correctly, you want to follow W. Edwards Deming's famous PDSA cycle. Plan, do, study, act. The absolutely crucial step here is step 3, study. If a team skips analyzing why a test turned out the way it did, they just fall into this incredibly wasteful plan, do loop. That's just motion without any real progress. Every single cycle has to answer. What did we believe going in? What did we actually test? What did we learn? And what needs to change next? Let me share a fantastic, real-world example of this. A software team built this beautiful search bar for an e-commerce site, and their customers completely ignored it. All that upfront planning couldn't predict human behavior. So, through iteration 1, they shipped a basic version, watched their users, and learned that customers didn't actually search by product name at all, they searched by category. Well, that changed the entire problem. So in iteration 2, they added category filters. But then, page load time spiked to 4 seconds, and users just abandoned the site entirely. Finally, in iteration 3, they optimized the database to fix the load time. They literally had to ship it, watch it fail, and revise it to figure out what the actual solution was. Next up, section 5, the exploratory process. Let's talk about navigating the total unknown. So, how exactly do you navigate when you're facing the complete unknown and you have absolutely no clear route to a solution? Well, when no proven path exists, you use the exploratory process. You start incredibly wide. You run super cheap experiments with the explicit, specific goal of killing off bad candidates as fast as humanly possible. By systematically ruling things out, you shrink what we call the cone of uncertainty until the real answer finally reveals itself. Now, a lot of people mistake this for just plain old trial and error, but actually, they are very different animals. Trial and error is unstructured. You usually end up repeating your past mistakes because you aren't really tracking what you learn. But true exploration, it's highly systematic. Every single exploratory experiment you run has to explicitly reduce uncertainty or eliminate an option off the table. You are prioritizing your hypotheses based on what's going to teach you the most, the fastest. Here's the rapid 5-step loop for structured exploration. You generate hypotheses, prioritize them, run cheap experiments, evaluate the results, and then update your mental model. And the crazy thing is, this works for almost anything. Whether we're talking about global scientists rapidly testing hypotheses in 2020 to invent a novel vaccine, or just a guy in a music shop trying out a guitar, then jumping to a keyboard, then banging on some drums to see which instrument naturally clicks with him. In both cases, you start super wide and use small, cheap tests to find your real direction. And that brings us to section 6, choosing your path and how to select the right tool for the job. So how do we systematically pick the right tools so we don't end up applying a sore throat fix to a chronic fatigue patient? Let's walk through a mental decision tree. Start at the very top. Is a failure here catastrophic or irreversible? If the answer is yes, you immediately use first time right. No questions asked. If no, you ask, is this problem totally familiar to me? If yes, use the primary process. If no, ask, can I clearly describe what a working solution even looks like? If you have no idea, you're bushwhacking. You need the exploratory process. But if you do know broadly what you want, ask if you can afford repeated, cheap attempts. If yes, that's your iterative process. The shape of your problem dictates the process. Understand the problem first, and this decision tree will literally hand you the exact tool you need. But listen, once you choose your process, there is one totally non-negotiable rule you have to follow. You must set stopping criteria before you even begin the work. You stop when the goal is met, when your assigned budget runs out, when a set time box expires, or when each new cycle is just giving you diminishing returns. Without these explicit stopping rules, human intuition just naturally defaults to endless continuation. We'll just sit there and keep tinkering forever, and nobody has time for that. I want to leave you with this final thought. Think about the biggest, most frustrating project sitting on your desk right now. Just picture it. Now ask yourself, are you using your current process just out of habit and personal preference, or out of a calculated fit for the problem? Because I promise you, a mismatch in process is almost always the hidden root cause of delayed, painful, and genuinely harmful work. Match the process to the problem and just watch how much faster you find your way. Thanks so much for joining me on this explainer, and I really hope this helps you navigate whatever big challenge you're tackling next.